Assalamualaikum warahmatullahi wabarakatuh. I thank Universitas Muhammadiyah Magelang for the scientific event, the second international symposium. Okay, now I will present our research result. Synthesis of acetin by base additive for low sulfur petrodiesel. The presentation starts from introduction, method, result, and discussion, and then conclusion. Okay, now introduction. Petrodiesel has now produced hydrocarbon gas, carbon monoxide gas, NOx gas, and particulate matter. This issue can be addressed by desulfurization. However, it causes a loss of lubricity properties. The fatty acid methyl ester or fatty acid ethyl ester, as known as biodiesel, can be added. But there are two things should be considered here. Unsaturated and saturated fatty acid chain content in biodiesel should be considered. Okay, unsaturated fatty acid chain here is susceptible to oxidize, and saturated fatty acid chain provide poor cold flow properties. So the researchers avoid how to solve this problem. They utilize glycerol as byproduct of biodiesel production, convert to chemical more valuable. One of them is acetin. Acetin, this compound can be synthesized through esterification of glycerol with acetic acid. And the other researchers propose transesterification of glycerol with ethyl acetate as a renewable feedstock. Okay. The last method need to be special apparatus and reaction condition. So in this work, we demonstrated how to produce acetin from renewable feedstock by means the simple reflux method. Okay. The condition reaction of this work is glycerol molar ratio glycerol ethyl acetate 1 to 10, 74 degrees Celsius for 10 hours, and sulfuric acid concentration 10%. And then the mixture introduced to spiratory funnel, added ethyl acetate and sodium bicarbonate, and settle overnight. After that, there are two layers formed. Upper layer is organic layer. Organic layer was evaporated to release the solvent, and finally we have the product. The conversion of glycerol to product in this work is 85.82%. And then the mixture was analyzed by thin layer chromatography. In here, there are some spots. We see the lower spot. We predict it is glycerol, and spot here is the first product, and spot here is the second product. And then the mixture of product was further investigated by GC-MS. From chromatogram of product, we find 3 peaks A, B, and C. A, it is predicted as reactant, and B and C are the products. Okay. Peak of B and C was further investigated by analyze mass spectrum. Here, mass spectrum of first product, we find M plus 134, okay, 34, and M per Z 117, and M per Z 103, and finally M per Z as specific 43. So from this mass spectrum, we conclude that it is monoacetic. Okay. Next, mass spectrum of second product. We have find M plus 218 here, and M per Z 145, and M per Z 43 as specific. So based on the mass spectrum, it is 3-acetin. Okay. The condition reaction of this work sufficient to produce acetin, although the conversion 85.82%. It means there is glycerol not yet unreacted. So based on this work, based on this research result, we suggest the product could be possibly increased by increasing the reaction time, and the system should be oxygen free. So the higher system's temperature can be reached. Okay. Finally, conclusion of this presentation. The first, the conversion of raw material into the product was 85.82% through a simple reflux method. The second, glycerol and ethyl acetate as renewable feedstock can be used to produce bio-based additive for low sulfur petrodiesel. So from this work, we have successfully synthesized acetin as bio-based additive for low sulfur petrodiesel. Here references. Okay, thank you for watch this video. Thank you. Assalamualaikum warahmatullahi wabarakatuh.